Hello and welcome to this demonstration of FLOEFD for Solid Edge. Today we're going to be looking at a stirred tank example where we have some paddles at the bottom with a motor to rotate that, and we'd like to understand what the mixing efficiency of the two fluids within this tank is going to be. So first of all, let's go over to our flow analysis tab and have a look at some of the general settings. We can see straight away this is going to be a time dependent or transient analysis, so we're going to be simulating over 2 seconds of transient. We've got gravitational effects turned on. We also have rotation with the sliding mesh turned on, so we're going to be using the moving mesh capability of FLOEFD. If we look at the fluids, we can see that we're mixing water and ammonia together. And under the initial conditions, we can see that at time 0 it's going to be 100% ammonia in the tank as the starting fluid. Now if we come over to our FLOEFD analysis tree, we can have a look at some of the setup here. So first of all, you can see that we have a rotating region on the paddles. We're moving at 240 RPM. The initial condition, you can see that there is a fluid level here. So the lower half of the tank is filled with water. If we look inside the properties here, we can see that we have water, 100% water at 38 degrees Fahrenheit, and we'd like to see what the mixture looks like at the end of that transient. So we can have a look at some of the results. The plot on the screen shows the mass fraction of water both on the paddles and as a 2D cut plot. To start, the lower half is red, indicating 100% water. As the transient progresses, we can see the mixing effect that the rotating paddles have. The paddles move the water up the outside of the tank and back down the center. This is the same plot, but this time colored by fluid velocity. We can see the high velocity region on the moving paddles. We can also see the flow develop as it moves up the inner sides of the tank and then back down the center. The maximum velocity of around 2,000 feet per minute can be seen around the paddles. Overlaying the ISO lines on the plot shows where the flow vortices are and how they move around over the course of the transient. Two distinct vortex regions can be seen where the bulk of the mixing occurs. Now let's have a look at an ISO surface showing where the boundary of the water lies. This moving surface gives an indication of the mixing plane in the tank. At the start, it clearly divides the two fluids, but as the transient progresses, we can see the chaotic mixing until there is no mixing plane as the two fluids have been homogeneously mixed. Creating animations like this in FLOEFD is very simple using the new Transient Explorer feature. By animating the flow trajectories, we can see how the virtual particles will move in the flow. We can see how the flow moves up the outside of the tank with a radial velocity due to the moving paddles. This has been a demonstration of FLOEFD for Solid Edge. Thank you very much.